plan this morning is we're going to start running the wiring with Clint here. He's come up for a bit to give us a hand, so we're going to start getting the wiring up into the wheelhouse. I'll show you what we're doing. In Brupeg's helm, we need to basically run our cabling systems going up to what's going to be the gauge panel over here, and then our screens, and then so driver's seat right beside me here. And on the roof, we're going to be putting a panel that has all of our sort of switches that we access regularly, like nav switches, radios, that sort of thing. So we need to start running cabling from our electric throttle, gauges, screens, and the switch panel above head, all the way down into the engine room. Under the floorboards in the wheelhouse, we've got this 3-inch pipe that Adam and I welded in, well, probably 12 months ago now, and basically this pipe goes all the way down into the engine room. I'll show you the other end of it here. This is the other end of the pipe. It's a 3-inch mandrel stainless pipe that works its way all the way down through the freezer room and off into the engine bay in the distance. And then the final end of that pipe comes through the engine bay. Bulkhead is welded onto the bulkhead watertight and just terminates here. We're going to put a stainless box that we made a while back onto the end of here, and then inside that stainless box we'll have all of our cable terminations, cable glands, that sort of thing, and it'll be a sealed watertight box. What we're trying to figure out, this box here is where all the cables terminate in the they go from the bridge down to the engine bay, and they finish up in this box and then go off to wherever they need to go. And we're just trying to think through every possible thing that can go wrong. And condensation is one of the things that we're thinking about, that the engine bay and the bridge are going to be quite different in temperature, but this is a sealed unit that is located in the engine bay, so it'll be the same temp as the engine bay, but it goes all the way through up into the bridge. The atmosphere's open up into the bridge. So we're just trying to figure out how do we mitigate like condensation running down the pipe and then dropping down into here and not being able to escape or anything like that. So
Clint came up with a good idea, eh?
Yeah. Clint's idea was just to basically chuck a bung in the bottom. We're going to put clear perspex on the front so we can see what's going on if there's water or whatever. And we're just going to stick a bung on the bottom, and then if we need to, we can periodically drain it. I'm hoping we don't need to touch it, but if we need to, we've got that option. And then if condensation does run down the pipes, we'll put a loop in the cables and we'll exit all the cables out the side rather than out the bottom. And that way it gives us more space on the side to put our cable glands, but it also gives us more ability to deal with condensation.
Yeah, better to be on the side of caution, eh?
Yeah. So the first step, this is our stainless box that we sandblasted just earlier. We need to figure out how many cable glands to put in there. So that's kind of a bigger question, which leads to this. What are we putting in the wheelhouse? So what we've done, we've gone through and we've made lists of everything that we can think of that's going in the wheelhouse, and then also how many cables we need or how many conductors we need for each of those. So this is a preliminary list. There's bound to be a lot more stuff going in here. So these are the things that are going between the wheelhouse and the engine bay. And then we started drawing out some diagrams of exactly what we're building. These things here, these are the diagrams for our fly-by-wire system. So we've got our throttle here. I just throw that over. So you've got your standard sort of throttle that you'd see in a trawler. But then what we've done is we've gutted all the mechanical Morse cable controls and we've started converting this to fly-by-wire. We're going to modify this a bit. This isn't the final design. But what the plan is when we look at these wiring diagrams that we've created here, it gives us multiple layers of redundancy. So we've got a minimum of 2 layers of redundancy, but in some cases up to 4. And there's automatic fail safes and things built in. So if one system dies, it immediately flicks to the other by default and so on. So yeah, there's quite a lot of work involved in thinking about what we're actually building before we can start cutting steel. So we've figured out now what we're doing with our DC current system, all the various voltages. We've got 48 volt, 12 volt and 5 volt. 6 volt. What we're going to do now is start working on this piece of paper. We're going to draw up a diagram for our 240 volt system. We need to do a couple of things. We need to make sure that shore power and generator power can't feed into the same circuit and start basically blowing things up. It'll make the boat live, and that starts getting interesting. So the plan is to try and automate a safety system using relays and so on, so that we can't actually double feed into the same system. So we're going through and trying to figure out cable length. So we've got our fly-by-wire system on the gearbox, and then on the throttle on the left hand side of the engine we've got oil pressure and start system. They'll go under the floorboards in this cable tray and then over to a battery box. We'll run them around the wall, all the way along this wall edge here, and then where that stainless pipe comes down, that's going to be where our stainless termination box sits. On this side we've got exhaust gas temps going to be mounted into the exhaust pipe here. We've got boost pressure which will go into that crossover pipe over the top, and then a water coolant gauge, and then also an alarm that'll be somewhere up the top. There's a couple of places for that. So it's quite a big run to go from this side of the engine across to the battery on the other side, across under that shelf, and then over to the stainless box. It's close to 10 metres just in this engine bay alone. So we've done a parts run. We've got bits all over the lounge. There's wires, cables, a bag full of goodies that we've got in here. So this is a whole bunch of switches and cables and stuff. Some more stuff sitting there waiting to be welded in through in the wheelhouse. We've got, this is going to become our new switchboard. We've got some decent cable. We ended up with some really three-core cable, and then some thinner 3-core cable, some conduit, and this is all going to go between basically under the floorboards in the wheelhouse here and the bridge. So what we're trying to figure out is basically what the layout of this box is going to be. We've got all of our cables. It sits like that in the wheelhouse, so in the engine bay. So all of the cables come through a 3-inch stainless pipe, and then we have to essentially terminate most of them in here. There's a couple that we don't, like the 240 volt single phase stuff doesn't terminate. It just carries on through this box and out through a cable gland. But we're going to use these type of connectors. So we've got a few different sizes. We've got, where are we? Large and small blocks, but we're going to have basically rows and rows of these so that we can bring all of our cables in and terminate them, and then decide where they're going to head off to on the other side, and then they'll be leaving this box via multi-cable conduit. So like it might be a 7-core cable that heads off, and it'll split off to a couple of different sensors on the engine, and we've grouped them so that there's non-sensitive. So we've got anything that's sensitive is basically split apart from other sensitive things like RPM and amps and things like that are split apart so that they're not going to interfere with each other. So yeah, fair bit of thought has kind of gone into the layout and how we're going to exit everything out of this box. Because we could do like this is M20, we could chuck another 2 like that, and then we can do another there. So we've got 1, 2, 3, 4, 5, 6, 7, 8 of the 7-core flex.
What about bilge pumps and stuff like that?
Yeah, that's going to need something decent. Hang on, we don't have to power this from the bilge, or do we power the bilge pump from the house bank or from the engine battery? You kind of want both almost.
I would keep it separate.
Yeah.
I would just pass the 240 straight through this box and out, and not do anything inside of here.
Yeah.
Because then if you you pull this open and you think it's all 12 volt and you go poking around, you accidentally touch the 240.
Yeah. Do you run a breaker at the generator end?
Yep, straight as close to the generator as possible.
want to put our 240 volt engine bay DIN rail box probably next to this one, like over here.
Yeah, probably just there. Yeah.
And then just straight out.
Straight out and into there, and then from there, then it can break out to 15 amps.
You couldn't feed them into the same. That stuff's messy, wouldn't you?
So
getting two converters and feeding them into the same.
Yeah.
You could
just double them up, two converters, join the wires on the output, and then you've got double the amps.
So what are we powering from the house bank?
Lights. So you can't accidentally send your engine batteries flat.
We're working towards welding this on, but before we can do that, we have to figure out where we're going to put all of these little cable glands, and that's leading to some significant project delays in the welding of this box. It's dragging on. It's taking days and days and days to weld this box in. So we started going through these with our hole saw, and we got most of the way through. We're not going to drill out all of those dots, we're going to leave them for later, but most of the way through the holes that we're going to do. However, we started killing our actual hole saw, so we have got one of these gadgets, Christmas tree style drill, and we're going to rip into it with those. Apparently they're a hell of a lot better than what I've been trying to do, so we'll give that a go. Alright, just going to go and sharpen your drill bit.
Yeah, it's still binding up at the last part, but it's getting most of the way, so we'll just swap out there. Try this, this doesn't seem to bind up at the end.
So one of the issues we had was heat on the drill bit just kept making it blunt. The stainless is hard enough to cut through on a good day, so we thought we'd pile in a heap of cold water like this to mitigate that problem. None of this worked, and we had to buy a 2-speed drill.
I don't know if we're really cutting.
Okay, so what the plan is this is the side of the box that all of our cables and so on come out of. This is actually the bottom of the box, it's upside down in this orientation. What I want to do is I'm going to weld in this little nipple and drain bung. I think it's like a 1/4 inch drain bung. It's basically, there's a slight curve in the bottom of the panel. It's sort of bent and warped when we welded it all together, which is to my advantage. It's the lowest point is basically right here. What I'm going to do is weld this bung in so that there's no protrusion on the inside. So the lowest possible point is a drain bung. I don't know if we're ever going to use this drain bung, but the thought is this box is basically a sealed box. There's going to be no way for air to get in or out of it, except for coming through the 3-inch conduit. So that big stainless piece of pipe on the wall there, that's essentially a pipe that's going to be welded solid to this box and go all the way through into the wheelhouse. So you're going to have the heat of the engine room on one end, and then it's open to the atmosphere in the wheelhouse. So we don't know if condensation is going to come down this pipe, but by putting this drain bung in, if it ever does become an issue, we can easily drain that system without it being a hassle. We just undo that bung, water will come out, do the bung back up, and problem solved until next time it fills up. So what the plan is we want to make this room fireproof as much as possible, so anything that can burn or melt or things like that, within reason, we're trying to replace with stainless or alloy, things like that. So wood floorboards are getting replaced with aluminium floorboards. You can get sort of really high temp rated cable, but it's astronomically expensive when you start getting into more specialty stuff. So we're not doing that, and that's kind of copying what a lot of the boats that are in survey do. They go to survey standards, and where possible they'll use those sort of cables, but a lot of them are just using sort of 3-core untinned copper cable, simply because it's just too hard to actually get the tin cable in a lot of the sizes that they need. So they have standards around sort of sealing up the ends and things like that that we're going to copy just to stop the corrosion from becoming an issue. But obviously that's always going to be a compromise solution, but it's in a lot of cases it's just not possible to get tin cable for what we need. So for us, we're going to be sealing the front of this box with either an aluminium panel, which is my plan B. My preference would be actually to use something like a half-inch thick perspex panel on the front, so that I can see in what's going on. I can see if there's water, I can see if there's any sort of issues with any of the cables or joins or anything like that. But I just don't know how that's going to go in terms of survey spec with like safety standards and stuff like that. So I have to do a bit more research on that. I can leave the front of the box open for now, so I don't have to solve that problem right now. That's kind of where my head's at. I'd love to be able to see in there, and if I can't, then obviously I'll just seal that up with some metal.
After drilling the box and days of thinking, we took the dog to the beach for a bit of a break.
It's been so long since I had time to think about it. Some say it's wrong to spend all your time
And I was just going to rip out the green one.
on one moment of joy.
Hi. How's it going?
In there.
Gosh, it's a good fly of air, isn't it?
Yeah, pretty good, eh? Cool. That's worked out really well actually. So when I've welded it, the heat's actually bent it slightly more, which for us is it's a bonus. It basically means the low point is even lower now. So yeah, no negatives there for us. That's really good. I'm happy with that. Right, we'll let that cool down. Sandpaper. So the reason why I scraped the paint off by hand and then sanded it by hand, it's pretty simple. It would have taken me 2 seconds to do that with a grinder on a flapper wheel and get a really beautiful finish capable of being welded to, but it's going to shower the engine room in dust and rubbish and sparks and all that sort of stuff. So I just want to be pretty careful down here. I'm sick and tired of having to clean the engine bay out every time I do work down here. So a real easy way of doing that is take like 5 times longer to do it this way, but it saves me all of the cleanup and everything. I can just now go through the vacuum and pick it up and it's a piece of cake. Job done real easy. So now that we've got those 4 corners scraped off down to bare steel, what the plan is, get the box mounted up onto the wall, weld all the way around the pipe, so the pipe is a sealed unit, and then weld the box on in the 4 corners so that it's going to be nice and stiff. That pipe, so in terms of vibration, if you're thinking maybe that'll vibrate loose and cause cracking and all that sort of stuff, that pipe is double continuous welded around its diameter where it goes through that bulkhead. So on this side and on the other side is a full continuous weld all the way around. And then it comes down as a straight piece of pipe essentially into that box, and it's going to be sealed. It probably won't be a double continuous into that box because I won't be able to get around the back of it on the top, but I'll be doing it all the way around on the inside and then most of the way on the top. So yeah, I'm pretty confident that should be okay. And if it's not and it cracks, so be it. It cracks, and I'll cross that bridge when we get there. But I don't think it will. I think it'll be all right. The pipe's got enough sort of flex in it that I think it'll be okay. And worst case scenario, maybe I just take all the cables back out and I'll put a flex joint in it or something like that, like an exhaust flex joint. But yeah, I don't know, see how we go. It's no big deal. We can, if we need to repair it or do anything later, I'll learn why it broke and then yeah, just resolve that and carry on. But that's today's plan, is get that box welded in and then we can start running these cables. So with the box welded in, you can see, so with the box welded in, you can see the weld at the top, and then if you come down to the bottom, you got the weld all the way around the bottom. It's pretty manky, so if you see right up in there, the weld's going to be too rough for wire. We need to clean that up. It has to be a nice smooth surface so the wire doesn't chafe. So we're going to go through now and flapper it on the inside, and then we're going to die grind out the actual inside of the tube so that we can make sure that we've got a really good surface for the cable to pass through.
Wow.
That's just tacked in pretty much.
Yeah.
Looks like a fireplace.
It does a bit. Wow.
Hopefully it doesn't turn into a fireplace.
Clint's gonna buy the buggy.
Yeah.
Congrats.
Look at this thing.
Yeah. That's fucking awesome. Have you been doing jumps?
Not yet.
Look at the size of the tyres on it.
So now that we've got that box welded in and sorted, we've cleaned up around the join where the tube meets the flat surface of the top of the box. We're going to start running some of these cables. So first up we're going to do our AC cables. So AC is going to be in the same conduit as DC, but we've done the calculations and we've talked to some people about this, and so long as we've insulated it enough, the conduit is well big enough to be able to deal with both of those. So we've got some 32mm conduit they're going to use, and then we're going to run our two AC cables. So one is a main generator feed, and then another is a 240 volt feed going back in, so we've got power in the engine bay.
Should be good.
Doesn't fit.
You're joking.
Oh, you're joking. We can't squash it either.
Oh, you know what we did?
We did two of them.
We did two of them, not fuck. We didn't think about the big one.
Yeah, so the issue that we're facing, this is I think 32mm conduit and this is 35 or something like that, and yeah, it's just not going to go. And we can't squash this down either. This is like a reinforced type conduit, so it's flexible, so we can bend it wherever we want, but it's really stiff, so there's just no way that we're going to get these two to marry up if we do it. So we're going to do two separate runs. This is a 16mm conduit to go over this cable, and the other conductor we've got, we can get into a 13mm plastic conduit. So that's what we're going to do. We'll put these two together now and then get them ready to run through the our main stainless pipe work. see what he's doing because the GoPro is replying on my phone. You can see how far away we are ready to pull these wires through.
Okay, it's good for you to pull on the rope.
Don't hold on too tight. You know you gotta try. Keep a love alive. Keep a love alive. Still here we are, my friend, over 10 years down the road. 3 kids in a big old house, can't weigh a heavy load. Life gotta give it to you, don't know how you find the time. Make it all ends meet while running down that line. Keep the love alive, it's a tricky thing. You gotta let it fly, you gotta give it wings. If you wanna make it right, blue man's right. Don't hold on too tight, you know you gotta try. Keep the love alive.
Just gonna get a craft knife. Back look through, I'm just gonna use a craft knife to cut all the grey stuff off. Can you remember what we did with the rusty craft knife?
I haven't seen it. Oh, there's one down here.
Oh, that'll do. Let's use that one.
I don't know if it's the one you want, but there's a yellow one there.
That'll work.
Yeah.
Where's the lid for that one?
Just here. Oops.
So this grey cable here is our main DC signal cable, so it's 17 plus earth, so essentially there's 18 1mm conductors that go through this big grey cable, and we've got to feed that down through where we've got those 2 black cables going now. There's 3 runs of this cable that we're putting in initially. We need 2, we're putting in 3, and if we have spare room we're definitely going to start loading more in, as it gives us redundancy for the future down this conduit. Alright, so I'm thinking we go out, along and up.
Yep. Yeah.
So some variation of this. We get to maybe there, and then we go up. So what we're doing is basically figuring out where our cable runs are going to go. So they come out of the hole in the ground. This is the battery box that we're in. They come out of the hole in the ground. That is the other end of the conduit, the stainless conduit. And then they head up to what's going to be our 240 volt breaker and panel box and everything that's essentially will be mounted under the driver's seat. We're putting it up there so that it's out of the way, you can't kick it. It's really hard to do anything stupid with it, but it's also incredibly easy to access. You just basically get up into the wheelhouse and look under the seat. Yeah, ready when you are. Okay. you can pull right back. These blocks of alloy here are the things that are glued in, and that's what these cable trays sit on. So these are just a galvanised tray, lots of holes in them. It allows you to put zip ties or whatever you need to run, multiple rows of cabling and so on down through. You get lots of different widths. We've only got a few cables that we need to run, so we're only using a 3-inch wide piece of cable tray for the stuff here. So these are the trays basically laid out. We've got to go through and pot rivet them all now. Just sort of. We've done a few like notches and stuff just to allow everything to fit in there neatly. I realised I made a bit of a muck up. I should have made these slightly higher so I can use the full width of this cable tray here, but it's all good. Yeah, I just realised I need to fold that over. So yeah, last few little jobs to do. We'll get this stapled down to these alloy straps, and then we can start running these cables. So while we're waiting for parts, we thought we'd check the alternator wiring, get that sorted, start the motor, and make sure we're getting charge happening in the system.
So yeah, we want to check what the voltage, we've got 12.55 now.
Yeah.
We want to see if that increases once the engine starts, and we want to check what the light bulb does, and then we'll shut the engine off. Alright. Light switch works.
Cool, we've had up.
Light bulb, 12.5 volts.
There we go.
Never had that trouble before?
Our trick with the fuel screw solenoid to turn it off didn't work. We couldn't actually turn it off. Okay, something's fucked up.
Alright, let's take the solenoid off and fix that as our next job.
Yeah, let's fix that.
Okay, so yesterday we've gone to do some testing on the engine. We wanted to work out how the alternator works, whether or not we need a lamp to excite the alternator and get it started, and also how to get the RPM gauge working by taking a signal off the alternator. We started the engine up, we were doing a bit of testing, then we went to shut it off and it wouldn't turn off. Damien wound in, there's a little screw on the side of the solenoid valve on top of the fuel pump. Damien wound that in and the engine just kept running. In the end we had to turn off there's a little, luckily Damien had a ball valve coming in the fuel line before the fuel pump, so we shut that off, waited about a minute and the engine finally shut down once it finally ran out of fuel. What was I guess left in the filter and the fuel pump there. So today, first issue was we really wanted to work out what's going on with the fuel solenoid. Why didn't it work? It hasn't worked for Damien at all yet, so we really wanted to pull that apart and find out what's going on. After pulling it apart, seeing how everything works, we've now bolted back together, started the engine twice. It starts and stops perfectly, and we're now good to get back to checking the alternator.
Heard you want to leave this place where we grew up. This old town, just put it all behind. Remember you and I would always find somewhere to hide.